Manoj Kumar, lead of GDC Info Institute of Engineering, to introduce our prominent speaker of the day.
Good evening, everyone. It's a pleasure to have you all here in this wonderful weekend evening. I am Manoj, the GDC leader of Info Institute of Engineering. I am extremely happy to introduce our esteemed speaker, Mr. Kanav Bansal sir, the Chief Data Scientist at Innomatics Research Labs and ZeoMind Solutions. He is not only a leader, also passionate about the open source contributions. His contributions are the best gateway for those who want to kickstart the career in data science and AI/ML. We are privileged to have him with us today. I am happy to hand over the session to you, sir. Now the stage is yours.
Thank you so much, Manoj. Just give me 1 or 2 more minutes. I'll try to set up my device. Looks like I won't be able to access the two devices. I'm trying to log in with another device. Just give me another 1 minute so that I can configure my other device with this session so that we can start with the discussion on today's topic.
Okay, sir.
All right. Good evening, everyone. I hope my screen is visible and I am loud and clear. Can somebody confirm that in the chat section or maybe unmute themselves and let me know? Perfect. Thank you so much for a warm introduction, Manoj and Janani. Um, Just to give a brief about myself, my name is Kanav Bansal. I bring somewhere around a decade of experience in the domain of data science. And today I'll be discussing about unleashing data, data pre-processing, and machine learning, building up of a machine learning model. And in order to do that, what I'm going to do is I'm going to share my screen. And I think it will be a little difficult for me to follow the chat. So what I'll do is I'll try to keep the chat section on the right hand side and maybe the screen annotation screen on the left hand side. Is this setup, like, are you all comfortable with this setup? Are you all able to understand the or able to see the annotation screen as well as the chat section on the right hand side? Perfect. So let's start our discussion on the topic without any further ado. Let me not waste any time because I think we only have 1 hour to complete this entire discussion. And the discussion we are going to do is a very big discussion, as in the discussion or the data preparation strategies that we are going to discuss during our discussion today. It is a never ending topic, but I will try to make it concise, keep it super simple for you to understand. But before starting the session, before starting the discussion on something called as data pre-processing and machine learning model development, how many of you are completely new to this area? Can somebody please tell me in the chat itself, like, if you have some experience in machine learning model development, or you are completely a fresher, completely new to this area of like model development and machine learning data pre-processing? Okay, completely a fresher. There are many people who doesn't have any idea on this part. Are you from first year? I think Manoj has mentioned that some of you are going to be from first year of your bachelor degree. Some of you are going to be maybe from some other years of year of professional of your bachelor degree, right? Anyhow, let me start my discussion by discussing what exactly is machine learning. Um, I think my handwriting is a little off. Manoj, can you please tell me, like, is it a possibility to attach the iPad to this meeting? Because I was trying to share my screen on my iPad. The problem I was facing was it was not allowing me to share the screen using my iPad. Is it like possible to do that? Do you have any idea on that, Manoj, Janani, anyone?
Yes, sir. We already gave the permission to your account, sir.
Yes, the presentation access is there, but the problem is when I click on share screen button on iPad, it is not giving me the access to share the screen. Are you getting it? So when I click on this share screen button, the option to share my screen on iPad is not coming, but on the Windows system it is coming.
Yes, sir. I got it, but I don't know about it
Okay,
properly.
okay. So the only problem with this is going to be it is not properly, this app is not properly synced right now with my Windows device, but I'll try to write neat in the interest of everyone. So as I was discussing, let's start the discussion. I was talking about something called as machine learning. Can somebody give me a quick idea of what your current like understanding is about this term called as machine learning? Oh, I see a lot of people from Inomatics has joined this session. But what is your current understanding or current idea about this term called as machine learning? Anyone? How many of you know that machine learning is a subfield of AI? Everybody knows that machine learning is a subfield of AI. Yes? Have you ever seen this kind of a Venn diagram where I can simply represent that, let's say this entire set represents AI, all right, and the subdomain of AI is nothing but machine learning, all right. And before getting into this diagram, okay, I won't be discussing anything about this diagram or what AI is, what machine learning is, because it is simply going to eat up all our time. Let me quickly tell you what machine learning is. See, from the name itself, if you try to focus on it, machine learning, right? So if you try to focus on the name itself, you will be able to understand that if you can make your machine, right, a machine can be your computer, it can be a robot, it can be something like your washing machine, it can be something like your air conditioner. Given that you have a machine, and if you can make your machine learn, all right, if you can make your machine learn from the available data, all right, let's say you have some data, and if you can somehow, if you can possibly make your machine learn from the available data, that process is called as nothing but machine learning. And machine learning specifically talks about three types of learning techniques. One learning technique is called as, let me try to discuss about that. Uh, so one of the techniques is called as supervised machine learning. One of the techniques under machine learning is called as supervised machine learning. There is another technique which is called as unsupervised machine learning. Unsupervised machine learning. Can somebody tell me what is the third technique under machine learning? Are you aware of it? There is something called as, it starts with an R. Yes, reinforcement learning. Everybody has heard about it, right? It is reinforcement learning. Now, in today's discussion, all right, the discussion that I'm going to do today, it is going to help you do something called as data pre-processing for any types of learning. Even it can be deep learning. Even if you are talking about deep learning, whatever we are going to discuss today, whatever data pre-processing techniques I'm going to discuss today, they will all be applicable not just for supervised machine learning, but it will also be applicable for unsupervised machine learning, reinforcement learning, as well as the deep learning. Whatever you do in deep learning, the first thing you have to do is you have to prepare your data so that your algorithms or your machine can understand the data. Are you getting it? So what we have to do initially is, before we start making our machine, you remember machine learning is all about what? Machine learning is all about use the data, pass the data to the machine, and you make machine learn from the available data. I have a very basic question for all of you. Can machine itself learns from the data, or do you need some external support to make a machine learn from the data? Can somebody give me an idea on that? Yes, as Hina has correctly mentioned, you require something called as algorithms, right? You require something called as algorithms, which will help you do something called as learning on the given data. And do you know the outcome of this entire process? What we typically do is, see, we all have a machine, right? Everybody is logging in to this meeting either via their mobile phones or maybe via their tablets or maybe something like a laptop or a desktop. You all have a machine, and you also have a lot of data on your machine. Do you all agree with that? You have a machine, you have a lot of data on your machine, but is your machine capable of learning from the data? No, right? It can't automatically do it. You have to introduce another component called as machine learning algorithms or deep learning algorithms or reinforcement learning algorithms, so that your machines can eventually learn something from the data. All right, and that learning from the data is termed as something called as a model. Have you ever heard of this term called as model? The word model is nothing but what you have learned, not exactly you, but what your algorithm on your machine has learned from the data. Is everybody able to at least understand the basic concept here? Everybody is able to understand the basic concept here? All right. Now, what is the title of this workshop? Can somebody tell me the title of this workshop? What is the title of this workshop? What is the title of this webinar? Yes, unleashing data, right? Unleashing data, unleashed, pre-processing and exploring machine learning. Now, my question is, let's say I have some data. Can I directly pass this data to a machine? Can I directly pass this data to an algorithm which is residing on a machine? Can I simply take some data which is nothing but some text data or maybe some image data? It can be any kind of a data, right? It can be text data, it can be image data, it can be a table containing numerical or categorical values, right? It can be a table containing numerical or categorical values. My question is, can I directly pass this all this data to a machine or this algorithm so that the learning happens? No. Yes, perfect. We can't do that. We have to make sure that everything, whatever we pass to this algorithm, that particular thing or that particular data should be properly pre-processed. There is a need of pre-processing the data. Do you agree that machine learning algorithms, some of you must be already aware of it, machine learning algorithms are nothing but mathematical equations. All right, they are nothing but mathematical equation. People who are into the domain of machine learning, you must be knowing that machine learning algorithms are nothing but bunch of mathematical equations working in order to learn from the given data. Now, if they are mathematical equation, can somebody tell me whether this thing that I've mentioned on the board is it a mathematical equation? Yes or no? Do you all agree that this is a mathematical equation? So if I want to find the value of y, if I want to find the value of y, given the data value equal to 1, can somebody tell me what will be the value of y for this x equal to 1? Y is equal to 1, right? Y is nothing but equal to 1 in this case. And in case if I try to change the value of x, what is happening? The value of y is changing, right? Based on the value of x, the value of y keeps on changing. What if I try to keep x equal to something like Kanav? Now, do you know what will happen in this situation? What will happen in this situation? What is the value of y if x equal to Kanav? Yes, it will be an error. What is the reason for that error? What is the reason for this error? Yes, the data I am passing, or whatever data I have passed in this variable x, the type of data is nothing but some string, right? It looks like a string, it looks like a word, it looks like a non-numerical value, as Pranav has clearly pointed it out. All right, this particular value that I'm putting over here, it is nothing but a non-numerical value. It is a non-numerical value, right, which needs to be converted to numerical value so that I can apply this formula on this word called as Kanav. Are you all able to understand it? So in simple terms, what I am saying is, if you think of this x variable as data, I can't directly pass this data to this equation, isn't it? I have to convert this x into something called as what? To numerical representation. Is everybody able to follow along till this point? All right. In order to apply a machine learning algorithm, or in order to apply this formula on this data, I have to convert this data to a proper numerical representation. If I fail to do that, the formula will not be applied. Or in simple terms, what do I mean by the formula will not be applied? It simply means algorithm will fail to answer appropriately. What do I mean by that? The model that you get, you won't even get a model, because the algorithm itself will simply break, saying that the data is not appropriately given to me. Is that making sense to everyone? It is not just about type conversion, Sampath. There are many more things that goes inside data pre-processing. It is not just about type conversion. All right. If I try to type convert, or if I do a type conversion, is it really possible to convert x equal to something like Kanav to an integer? Is it really possible to convert this variable x to an integer? It will simply throw an error, right? I'm not talking about type conversion. I'm talking about representing this word Kanav in a numerical format. Are you getting it? I'm talking about representing this word Kanav in a numerical format. Can I take an example just for the sake of understanding of this concept in much more better way? Let me take an example, okay? Let's say I have a data which contains two columns. One column is nothing but the height column. Another column is nothing but the gender column. This is the height column, and the other one is the gender column. Height column contains height of few students, maybe few out of 102 participants in this meeting. This height column contains the height of few of the students. Maybe let's say the first person has a height of somewhere around 155 centimeters, and their gender is female. Second person has a height of maybe let's say 180 centimeters, and let's say the gender is male. The third person, let's say, has a height of maybe somewhere around 170 centimeters, gender is female. And the last person has a height of somewhere around 175 centimeters, and the height and the gender is nothing but male. All right. Now the question is my algorithm capable of taking this data as it is? See, I was talking about a machine learning from the data. Machine has to learn from the data, and the outcome of that learning is going to be called as what? Outcome of the learning is going to be called as a model. And who will help us, or who will basically allow us to do this learning? Something called as a machine learning algorithm. And what did I just tell you? I told you that machine learning algorithms are nothing but some bunch of mathematical formulas. These are nothing but some bunch of mathematical formulas that allows you to learn something from the data. It is all about machine learning from this data. Have you ever given any examination? You must have given multiple different examinations, right? You must have given examination for IITs, triple ITs, NITs, MBA colleges, civil services. You must have given so many examination. Have you ever noticed before the examination, what do? You use your brain, you use yourself, and you try to do something called as learning. Using your brain, you try to learn on what? You try to learn on lots of data related to what? Data related to the examination that you want to attempt. Are you all able to understand that? And what is the outcome of that learning? In simple terms, your mind becomes tuned. Your mind becomes tuned to the type of questions that can be asked in that examination. Do you all agree with that? Yes or no? Before the examination, what a human does, before any examination, as a human, what we do is we try to take the relevant set of questions and answers, and we try to keep on revising those questions and answers. We try to keep on understanding the fundamentals behind all the topics that can be asked in the examination. Now, what happens with that entire process? We will be able to learn something from the given data. We will be able to understand the patterns in the data, in the questions that will be asked in the examination. Now, with this model, with this learning, what is the end product? Do you agree with this model or with this learning? What we typically do is we go and sit in the final examination. Do you agree with this learning? We go and sit in the final examination, and with this learning, what will be able to answer? We will be able to answer all the questions, right? Whatever question comes in the final examination, we will be able to give the answers to those questions in the final examination. Is it making sense to all of you? Is it making sense to all of you? Yes or no? All right. So let me try to bring back this example. What is a problem in this case? What is the problem in this entire case? Can somebody point out the problem? Can somebody think of the problem in this entire case? You have a machine. Everybody has a computer, right? Everybody can learn about the algorithms. And if you know the algorithm, if you have a machine, you can simply train something called as a model. You can simply learn from this data. But what is the problem here? Yes. Do you see that in order to pass the data to the algorithm, what should be taken into consideration? What should you consider before passing the data to an algorithm? You should make sure the data is in numerical format. Is height column a numerical column? Is height column a numerical column or numerically formatted data? Yes. But what about gender? Is gender a numerical column? It is not a numerical column. So what if your algorithm internally tries to find the square of this female, or cube root of this male, or maybe something like a logarithm of this particular female, or maybe something on this particular male? Will it be able to perform all those mathematical operations on the data? No, it won't be possible for the algorithm to perform all these operations on the data. So what is the need? What is the problem here, and how do we resolve it? The problem here is data is non-numerical in nature, and there is a need of doing what? There is a need of doing something called as data pre-processing. Everybody understood the need of data pre-processing? Perfect. All right, so can we now look into few important data pre-processing strategies? Can we talk about few important data pre-processing strategies? All right. I know my handwriting is too bad because the software is not properly supporting this external external digital pen and pad that I'm using right now. But I'm trying my best to properly write the words. If in case you are not able to understand something, you simply ask me the question directly in the chat. What you have written on the screen, can you please explain it again? All right. So I will appreciate if you can do that. Because This particular device is not supporting properly the annotations over here. All right, so let me try to now come back and try to help you understand like what are various different data pre-processing strategies. Now, in order to understand data pre-processing, please understand that the data that you get, first of all, I will try to mention the data that you can get into multiple different buckets. You can get something like numerical data. You saw earlier, I told you, let's say you have a data set containing heights and gender, right? So the data can contain columns which are numerical in nature. What else can data contain? Data can contain categorical columns. Everybody agrees to that? What else can be the type of data? Do you agree data can also be text in type? You can have something like text data, right? For example, emails. You get lots of emails. Now, these emails, what are the type of these emails? Emails are nothing but text in nature. Yes, data can be something like a image or video format data. Data can be either image format or in a video format as well. Okay, I'm putting image and videos together, and somebody is clearly mentioning something like a audio, right? Audio or sound, right? Data can be in any of these different types. Now, the question is, if data comes in numerical type, is there a need of pre-processing the data? Yes, that is a completely different story. That is nothing but something called as data cleaning, when the data is null or data is out of like something like an outlier data, right? So in that case, we need to do something called as data cleaning. But let's not worry about the data cleaning right now because we have very limited time. So let's talk about something called as a data pre-processing technique that can convert your data, convert all the non-numerical columns. Can somebody tell me what are the problems with these type of data which I'm trying to highlight in red color? I'm trying to circle all this data in red color. Can you tell me what is the problem with all this type of data? What is the problem with all this type of data? Yes, that is a good suggestion. I'll close the participant section. Yes, all the data that you see in red circles, right? All the data that you see in the red circle, all that data is non-numerical in nature. Do you see that? Do you observe that? The data that you see in red color, all of that data is non-numerical in nature, right? And even the bigger problem is, as Uday has clearly mentioned, Hina has clearly mentioned, data is completely unstructured, right? So, do you agree that let's not worry about even the unstructured data? Let's try to talk about the data problem. The real data problem here is it is non-numerical in nature, and I can't apply a machine learning algorithm to do any processing on this data to learn something from this data. So, what should I do? Do you agree I should make sure that the text data gets converted to something called as numerical representations? Do you agree I need to convert text data to numerical representation? Similarly, do you also agree I should do something about this categorical data also so that it becomes or it gets converted to numerical representation? Even on image data as well as video data, I should do something so that the data converts into numerical representation. And even on this data, I should do something so that data gets converted to numerical representation. Is everybody with me till now? Like, are you all able to understand whatever is happening? Perfect. Now, the question is, when I say data pre-processing techniques, what are data pre-processing techniques? Data pre-processing techniques are those techniques that can help you convert your data into something called as numerical representation. Is that making sense? Or I can say one of the data pre-processing. See, when I say I have to convert my non-numerical data to numerical representation, this technique specifically is called as vectorization technique. There is something called as vectorization, and this is what is called as vectorization technique whenever I'm trying to pre-process the data. There is one more thing. See, under data pre-processing, let me try to mention that there are two things we typically do. Do you remember somebody was talking about null data, outlier data? So we also try to do something called as data cleaning. All right. After doing the data cleaning, we try to convert all the garbage, not the garbage data, but all the non-numerical data must be converted to something called as numerical representation. And what do I call that technique? What do I call that technique of converting non-numerical data to numerical representation? What did I just mention? What is that technique called? Vectorization. Perfect. Is it clear to everyone? Like, what is a vectorization technique? All right. Now, can I tell you? Can I mention few vectorization techniques for text data? Can I talk about few vectorization techniques for text data so that you can maybe, if possible, look into that after the session? All right. One of the very popular vectorization technique for the text data is called as bag of word, BOW, representing bag of word. Please try to note it down. If I try to note it down, I think it will take forever for me. So I'm not going to note down the complete name. You just mentioned BOW means nothing but bag of words. The second technique, which is much better than bag of word technique, is called as TF IDF. Anybody who knows about the full form of TF-IDF? Yes. Term frequency inverse document frequency. TF means term frequency. IDF means inverse document frequency. Guys, is everybody able to understand? I need a yes or a no in the chat section from all the participants. I think we have somewhere around 105 participants. Can I please get a confirmation of quick feedback from all the participants? All right. Now the question is, are there, perfect. Thank you so much for reverting back. Are there other techniques that can convert the text data to numerical representation? And definitely there are many, many, many techniques. Let me tell you something that Google came out with. Everybody knows about Google, right? Right? So Google came out with a technique, a very, very, very powerful, popular technique called as word2vec, all right, which was used in 2013, all right, only 10 years back. Okay, I'm talking about something which was used 10 years back, or like which Google came out with 10 years back, and that technique was called as word2vec. And do you know word2vec was a technique which converted, which simply transformed the entire landscape of NLP. Whenever I'm talking about text data, I'm talking about simply something called as NLP related problems. When I say NLP, NLP ka full form is natural language processing. All right. And in natural language processing, majorly we talk about what kind of data? We talk about the data which is text or textual in nature. Guys, are you all able to understand this? Now, is there any other technique which can help us? See, it is something which was given by Google back in 2013. All right. And that was a time when everybody from bag of word and TF-IDF, they simply jumped into word2vec. They simply jumped to something called as word2vec. They never looked back on bag of word, TF-IDF kind of techniques, because word2vec was so powerful. It was so interesting. And it used to give a very good numerical representation of the text data. Now, there was another technique which came just after word2vec, and that technique was called as glove. Yes. Do you know who came up with this glove? This technique called as glove. Glove ka full form is global vector encoding. GLOVE. Full form is global vector encoding. Stanford came out with this technique. Stanford, everybody has heard about this university, Stanford University. They came out with this technique called as glove. All right. Similarly, there was another technique that came around 2014, 2015, which was called as fast text. Fast text. FAST, fast text, which was given by a company called as Facebook. All right, these big companies, these big universities, they were doing so much research in the area of converting text data to numerical representation that they came out with some of the very advanced state of the art techniques to convert text data to numerical representation. Do you agree that if these techniques were not available, will it be possible for us to do anything related to text data in machine learning or AI? Can we really do anything on text data or like in machine learning or AI without the help of these techniques? Why? Can you tell me why? Why no? Why can't we do anything without these techniques in the area of machine learning or AI? Why can't we do anything without these techniques? Because these techniques are fundamentally going to convert the text data to numerical representation. Yes, you need the numerical data. These techniques are simply going to allow you to convert all the text data to numerical representation. And now once you have the numerical representation, you'll be able to work on top of it. Are you all able to understand the need of these techniques now? I've been reiterating the same concept again and again so that you all understand it. Right? Now, after these techniques, there were different set of techniques which were invented. There is something called as RNN LSTM's GRUs. You must have heard about these terminologies from deep learning courses, right? These techniques, they work phenomenally well when it comes to the text data, and they try to handle the problems that these techniques, earlier techniques, used to have. This was very popular back in 2015 to 2020. But now, recently, there is another thing. Yes, RNN means recurrent neural network. Recently, everybody has shifted to something called as, have you ever heard of something called as LLMs? Everybody out there is talking about LLMs nowadays. Everybody is talking about something called as GPT. Have you ever heard of GPT? Chat GPT. You must have heard about something called as BARD, BARD, right? You must have heard about something called as BERT, BERT, right? What are all these things? They are nothing but applications of LLMs. Are you all able to understand it? LLMs have completely transformed the landscape of NLP, and it is a very recent advancement in the area of like text to numerical representation transformation. Can I tell you what is that LLM called? Like what is that LLM? Like typically, most of the LLMs nowadays, they are based upon a architecture called as transformers. Have you ever heard of this term called as transformers? Most of the LLMs, when you say chat GPT, do you know what that T means? That T in chat GPT means transformers. When you say BERT, what does that T means? That T again means nothing but transformers. Almost lot of techniques that are out there right now in the area of deep learning, in the area of AI or NLP, they are influenced from something called as transformers internally. Is everybody able to understand like what are the various different techniques you can use to convert your text data to numerical representation now? All right, so if you want to learn the area of NLP or how to work on text data, please try to follow this sequence. If you follow this sequence, it will make it very easy for you to understand all the techniques, because all of these techniques, they are nothing but one step ahead than their previous techniques. For example, if you try to learn about glove, it is something which is on top of something called as word to vec. Whereas RNN, LSTM, GRUs, they are a little different techniques, not exactly something which is coming, because see, all these techniques, they don't talk about sequential data, but this technique talks about this RNN, LSTM, GRUs, they talk about something called a sequential data. So what are all these techniques written in white color? Can I say that these all techniques written in white color, they are nothing but, what can I call them? What can I call them? What is the name I gave earlier to these techniques? Can somebody point out what was that name? Perfect. Yes, vectorization techniques, embedding techniques, vectorization techniques. I hope you all are able to understand it. Similarly, when it comes to image data and video data, do you know that in image data or video data, Let me directly tell you the technique which is right now used by most of the people in order to convert image data to numerical representation. And that technique is called as, that algorithm is called as nothing but CNN. CNN is a technique that helps you do something called as vectorization. On what kind of data? It helps you do vectorization on image or video type of data. Even, do you remember something called as transformers in NLP? You remember I told you transformers are state of the art, or they are the cutting edge right now in the area, in the domain of NLP. Similarly, people are experimenting with something called as vision transformers nowadays. By default, transformers are used to solve text data problems, but people are experimenting with this thing called as vision based transformers, not the text based transformers, but they are also experimenting with something called as vision based transformers. Is everybody able to understand the two major techniques that are used under image and video data to convert the data into numerical representation or vectorization? For vectorization, yes. All right. Now comes the audio data. Let me try to tell you one technique. Let me just give an idea, or let me just try to tell you the name of one technique that is very like popularly used under audio data. That technique is typically, yes, as Pranav has clearly mentioned, that technique is called as MFCC. All right. And the full form of MFCC is Mel Frequency Cepstrum Coefficient. All right. Mel frequency, MEL frequency Cepstrum coefficient. All right. This technique is typically used very heavily under audio data or sound data to convert the data to what? What these techniques do? They simply try to convert the data which is audio or sound signals in nature. It tries to simply convert that data to numerical representation. Guys, are you all able to understand till this point? Yes or no? Yes. So there are so many techniques I just wrote, but I didn't write something for categorical data. And this is one of the easiest possible data to transform to numerical representation, right? So let me try to come down and try to mention what are the numerical transformation techniques for categorical data. For categorical data, there are two very popular transformation techniques. One of the technique is called as one hot encoding, OHE, one hot encoding, and another technique is called as label encoding. Yes, correct. There is another technique which is called as label encoding. All right, label encoding or nominal encoding, you can call it anything you want. Is this making sense to all? Are you all able to understand it? Now, for this session, what I'm going to do is I'm going to talk a little bit more about categorical data instead of digging deeper into other pre-processing techniques. Do you know how much time does it take for a person to learn all these techniques? Can somebody tell me how much time typically it takes for a person? If you really want to learn it from really good resources, how much time will it typically take to learn all these techniques? Yes, it takes not exactly 2 to 5 years, but if you are really very focused, you can easily learn all these techniques within 1 year. All right, within 1 year, you can easily become a master of all these techniques, given that you have enough aptitude to understand all these techniques. Because in order to understand these techniques, there are lots of fundamental topics you have to study. It is not just understanding these techniques can be done from just out of the box. You have to understand a lot of fundamental techniques to understand these techniques. You know that CNN is a special type of it is a special type of artificial neural network. Everybody has heard about a term called as artificial neural network in their bachelor's degree, or you must have heard about this term called as ANN, or artificial neural network. Even when I say RNN is a special type of artificial neural network. In order to understand machine learning and deep learning itself, the basics of machine learning and deep learning itself takes up to 6 months to 6 to 8 months, right? And on top of it, I'm saying that it takes up to 1 year of your time will be consumed if you want to understand all these things in depth properly, as well as you have to understand, let's say, all the applications that these techniques can really help you solve. Okay, it is not a small area, and that is the reason why you must have seen recently, like nowadays, a lot of colleges, a lot of universities, they are coming up with their own machine learning or data science bachelor's degree, which takes up to 4 years of your time to complete. Because machine learning, data science, see, I just told you few topics of machine learning and data science over here, right? But on top of it, there is a lot of computer science also you have to study in order to become a good machine learning or a data scientist, machine learning engineer, or a data scientist. All right. So if you talk about data science or if you talk about machine learning, it is like an interdisciplinary field. All right, where a lot of other topics from various different domains, various different techniques comes together to help you solve real world problems. Can somebody tell me few machine learning applications? Are you aware of some of the few machine learning application that we use on a day to day basis? Can somebody give me some ideas of what kind of machine learning applications we use on a day to day basis? Perfect. Have you ever seen, let me try to go one by one. Somebody mentioned something called as spam detection. Can you tell me where do you see spam detection in real life? In real life, what is a platform where you see spam detection working at its best? Emails. Perfect. Do you agree, if there is no spam detector, if there is no spam filter, don't you think that your 50% of the time is going to completely get occupied by understanding which email, whatever is coming to your inbox, is a spam email where you should put your focus and where you should not put your focus? Right? It becomes a very tedious task if there is no spam filter out there. All right. Speech recognition. Yes, as somebody has mentioned, speech recognition. What is the utility of speech recognition? Don't you think we all use speech recognition here and there? Every day you might be using speech recognition without even utilizing, without even identifying whether you are really doing it or not. Yes, whenever you are trying to talk to your mobile devices or to these voice assistants, what are these voice assistants? One of the very popular voice assistant is Alexa. In Apple, there is something called as Siri, right? For Apple, there is something called as Siri. Can you tell me which company does Alexa belong to? For which company is Alexa working for? Anyone who knows about it? Amazon. Perfect. Right? Amazon has created something called as Alexa. Who has created Siri? Apple has created Siri voice assistant. Have you ever heard of something called as Cortana? I think Cortana, right? Cortana, something like that, right? So which company has created Cortana? Yes, Microsoft. Right? Similarly, Google Assistant, in its name itself, it is clearly seen that Google Assistant, GA, it is nothing but from Google. Right? Similarly, every company has one or the other voice assistant. Even nowadays, banks, have you ever seen that when you go to HDFC or maybe some other banking websites, you will see that they also have their own voice assistants or chatbots which will help you solve your queries on a day-to-day basis, right? So if you see it, machine learning, AI, it is all around us nowadays. In every application or every software you use, it is all every have you ever seen every application, every hardware device that comes, every software comes nowadays, they all say that we are having AI inbuilt, right? They will say we have AI capabilities inbuilt in our applications or in our hardware, right? So when they say AI capabilities inbuilt in the hardware, they are talking about they have very strong GPUs. All right, they say that they mean to say that they have very strong GPUs. For example, if you talk about Apple devices will typically come with a separate GPU which is going to take care of all the AI related stuff or very heavy like parallel computing kind of a task. All right, when you say that our application is AI capable or data driven, then it means that your application must be using one of the machine learning algorithms internally or a deep learning algorithm internally to perform certain tasks. I believe most of you can write 100 different applications here, right? Do you all agree that almost everybody knows what these applications are nowadays, because they are becoming so popular that we all are becoming a daily customers or daily users of these applications. Right now, we were discussing about something on the left hand side. Let me try to come back to that. All right, let me come back to the main discussion for today's session. And that main discussion for today's session is something called as categorical data. All right, one hot encoding, label encoding. What are one hot encoding and label encoding? Yes, even Zomato, Swiggy, Zomato, every website uses chatbots nowadays. Chatbot again is a application of machine learning or deep learning. Yes, Apple has this bionic chip which helps devices do a lot of AI, like on that. Like you can think of it as an edge device doing all those like tedious AI related operations. Yes, perfect. Now, let me try to take you back to the data that I showed you earlier. If you can remember it, I showed you a data set which contained two columns. One of the columns was height column, another column was gender column. Height and gender column. Do you remember that gender column was containing values like female, male, these kind of values? Whereas height column was containing the height of these people in centimeter, which was a numerical value. For example, the first female, I mentioned that she was 155 centimeter, male was 180 centimeter, this female is 170 centimeters in height, and finally this male is 175 centimeters in height. Now the question is on this data, which column needs to be pre-processed for sure? Can somebody help me understand that? Which data or which column must be pre-processed? Perfect. The column that needs to be pre-processed is called as a gender column, because that gender column is not in a numerical representation or numerical format. So definitely what I have to do is I have to convert this column into numerical representation. And do you agree that what I can do is, can I represent all the M male data points with a 0? Can I simply map all the male data points to 0 and female data points to 1? Don't you think it is a very simple way of converting all the data to numerical representation? Yes, and this is what one hot encoding or label encoding tries to achieve. Label encoding as well as one hot encoding, what they really try to do is they try to convert all the non-numerical data into numerical representations by doing certain processes internally. Is everybody getting this idea? So can we look into one implementation really quick? Can we look into one implementation really quick if everybody is able to understand what pre-processing techniques are available out there? All right. And we have already seen how much time it will consume for you to learn about all these pre-processing techniques. Whatever pre-processing technique is popular in 2024 right now, I have mentioned almost all those pre-processing techniques right now on the board. All right. So if you are a person who wants to become an AI engineer or a machine learning engineer or an NLP engineer or a computer vision engineer, or you want to do research in this domain, please try to explore all these techniques that are written in front of you so that you can start doing some good projects as well as you can start working in the domain of AI or machine learning. All right. And it is not a joke to complete all these techniques. It definitely requires a lot of practice, a lot of patience in order to learn all of it. All right. So let me try to come back to my browser window so that I don't have to write with this dirty handwriting. I wished I was able to draw properly on the screen so that I could have mentioned a lot about these techniques. But since I don't have that capability right now to draw properly on the screen, I'm limited to show you few things only. All right. So what I'll do is I'll go to my GitHub repository. I'll go to my GitHub repository. In case if you are new to this domain, I would suggest you to follow this GitHub repository. I know that many of the participants are college students. All right. So what I would suggest you to do is please try to take this link. I will be pasting this link in your chat section. Try to take this link and try to go through this GitHub repository. Everybody knows about GitHub, right? So if you are not aware of GitHub, please try to research about it and try to go through this link. It will give you all the desired topics that you need to learn in order to become a data scientist. So it is owned by me. So whatever you see on this entire repository, it is completely open sourced. So you can read and understand all the topics starting from Python programming, data analysis, advanced data analysis, machine learning, ML ops, multiple different case studies, deep learning, and how to prepare for interview. Everything is mentioned over here so that you can have a good time in the domain of data science or machine learning. All right, so let me try to come back to this module number 4, which is machine learning module. And on this folder or on this repository, what I'll go to is, I'll go to which topic are we talking about. Do you agree that we are talking about something called as data preparation or data pre-processing and machine learning modeling? Everybody agrees that we are talking about the first folder over here. So let's try to go there. And in this, I will try to open up the first folder, which is hands-on. And in this hands-on folder, I'll go to the code, and under code, I have a Jupyter notebook. Is everybody aware about Jupyter notebook? Can I get a quick response from all the people who are aware, not aware? I know that most of you are aware, but how many of you are not aware? Is there anybody who is not aware about Jupyter notebook? See, if you are not aware about Jupyter notebook, understand that in order to create something called as a document, we typically use something called as a Word, Microsoft Word. All right. Similarly, if you want to write your data analysis, or you want to analyze your data or represent your data analysis to somebody, what you have to do is you have to use something called as a Jupyter notebook, which has a very nice functionality. What is that functionality? Whatever code you write, for that code, you will be able to see the outcome there and there itself. Okay, then and there itself, you'll be able to see the outcome of all the code that you write over here. All right, IPYNB. Can somebody tell me this extension IPYNB? What does it represent? Is anybody aware of what this IPYNB extension really represents? What is the, yes, I means interactive. All right, do you see this is an interactive notebook? Interactive in terms of what? Whatever code I am writing, I will be able to see the outcome of that code there and then itself. That is the interactive component of this notebook. All right. And PY, what is the meaning of PY? PY represents Python, interactive Python notebook. All right. So I'll be able to do all the tasks, all the things I want to do, I'll be easily able to do within this notebook itself. All right. And let me try to show you quickly like what we need to do in order to work on maybe something like this, or let me try to go to some other case study and show you a bigger case study instead of a smaller case study over here really quick. Now, the case study that I have right now in front of me is to predict something called as a price of a diamond. All right. Given a diamond, can you predict the price of a diamond? All right. It is a very interesting case study. And the reason for that is predicting the price of a diamond is not that straightforward the way it is for gold. In order to predict the price of gold, it is super easy. But when you try to predict the price of diamond, it is not that easy, because price of a diamond depends on multiple different factors. There are many features on which the price of a diamond really depends on. If you want to read more about diamonds, please try to go through this diagram or this image that I have shared. All right, I'll be sharing the link to this notebook as well, so that you can open it up in your system and you can see what I'm talking about. All right. So if you try to see this chart, you'll be able to understand that there is something called as a color feature of a diamond. If the diamond is completely colorless, it is going to be of much worth more. The value of the diamond will be more compared to a diamond which is light yellow in color. Similarly, clarity. There are diamonds which are completely internally flawless. Do you see this is completely internally flawless compared to a diamond like this? What do you see? What difference do you see in the internally flawless diamond versus this included diamond? Yes, there is some impurity. Do you see? There is some impurity included in this diamond. And if you want a very expensive diamond, what you need to look at is you need to look at some diamond which is completely internally flawless. Right? Similarly, there is another very important property of a diamond. Everybody knows about carat, right? So based on this property, again, the price of a diamond can easily be identified. All right. And all these factors all these factors works together in order to determine the price of a diamond. It is not just the color or the clarity of a diamond that determines the price. It is also the carat which determines the price of a diamond. We have to include all these 3-4 different features together in order to understand the real price of a diamond before proceeding forward. All right. And do you remember, as I already mentioned, in order to transform your categorical data into numerical representation, either you can use something like a one-hot encoding or a label encoding technique. And in this notebook, I've clearly demonstrated how to do that. Let me quickly make you go through this entire code so that at least you have a basic idea about this notebook. If you are completely unaware of the code, please try to go back to other notebooks or other files that are available in my in this particular GitHub repository, so that you can prepare yourself to understand what this code is trying to do. Now, the initial thing that I'm doing is, can somebody explain me what is this initial part of this notebook? I'm simply trying to import few libraries, right? These are few libraries that I'm trying to import so that I can utilize these libraries to analyze the data as well as to build the model. Most of the libraries that you see over here, the first two libraries are used to manipulate the data, read the data, and perform some transformations on the data. The next two libraries that you see over here, these libraries are specifically used to visualize the data. Yes, they are used specifically for visualization of the data. Now, let me try to first use something called as a pandas library. All right. So if you try to say I've renamed pandas as PD, I'm using that library to read the data. All right. What data am I reading? A data which is present in this file called as diamonds.csv on my computer. I'm simply trying to read it inside a variable called as df. Once the data has been read, I'm going to print the head of the data. When I say print the head of the data, it simply is going to show me the top 5 rows in the data. Do you agree that a tabular data is going to have many rows and many columns, right? A tabular data is going to have many rows and many columns. And what do we see over here? What are all these highlighted values? Are they representing rows or are they representing columns? The highlighted items on the screen, what are they represent? They are representing the columns. If you want to see the row, this 0th value, this entire thing represents first row, this entire thing represents the second row, this entire thing represents the third row, and so on, up to multiple different rows. I can only visualize using this code the top 5 rows. If I want to visualize more rows, the top 10 rows maybe, in that case I can simply put inside these parentheses, I can mention the number I want to visualize. All right. Now, if you want to read more or understand the data features, when I say data features, if you want to understand what this means, what this variable means, what this column means, what this column means, and what this column means, and so on, you can go through this entire data description that I've shared over here. You can find it out on this link that I've shared earlier. Now, everywhere, whenever you do a machine learning, please remember that EDA is a most crucial part of machine learning. Please understand that if you are weak in EDA, see, EDA is like art. Do you all agree that in order to become a really good painter, or in order to become a really good dancer, or in order to become a really good actor, what is common thing that all these people have to do, all these artists have to do? Can you tell me what is a common thing they have to do? Practice. Perfect. Right? Do you agree that if you do not practice properly, if you are not properly practicing, or if you are not consistent in your practice, will you ever be able to become a good artist? Will you ever be able to become a good artist? Never, right? Same way, please understand that EDA is like an art. I would say that it is like an art, because there are very few data analysts or data scientists I have so far met in my career. I've met a lot of data scientists, but people who are really artists, or they have that artistic thinking about EDA, I have met very few only. All right. The reason for that is it comes with a lot of skill set. You need to have a very interesting, very good data analytical skill set. There is something called as data analytical skill set. And if you are weak in data analytical skill set, it becomes very difficult for you to become a good exploratory data analyst or data analyst. All right. And this skill comes with thousands of hours of practice. If you are not practicing, becoming a good EDA expert, is next to impossible. All right. If you see somebody doing a really good EDA, means they have practiced more than maybe hundreds of hours on their time on EDA or doing the EDA. Let's try to proceed forward. When I say DF shape, what does DF shape tells me? It tells me how many rows and how many columns do I have in my data. Can you tell me how many rows do I have? How many diamonds do I have? I have somewhere around data of 53,940 diamonds, and each diamond, right? It is represented by how many columns? Each diamond is represented by 10 columns, and 10 columns means nothing but 10 different features. I am representing each diamond with 10 different features. Do you remember earlier I represented a student with two features, height of a student and gender of a student, right? These were the two properties of the students that I used in order to represent a student. Similarly, whatever diamonds I have, I'm trying to represent those diamonds with these 10 different features. And how many in total diamonds do I have in this data set? 53,940 diamonds. Similarly, if you try to go down, you'll be able to see df.columns, which will tell you all the column names, df.info, which will simply give you an complete information about all the columns, along with how many null values are there, how many missing values are there, or what is the data type, what is the total size of the data that you are using right now. All these details can easily be understood from something called as df.info function in pandas. All right. Next, what I'm doing is I'm trying to create a very simple plot. This plot in data analysis is called as a anyone who can tell me that? What do we call this plot if somebody is from a background of data analysis? Yes, this is called as a bar plot. All right, this is called as a bar plot or a count plot. I can call it a bar plot or a count plot depending upon which library I am using. And this plot is helping me identify or understand the distribution of cut feature, color feature, and clarity feature. If I try to go down, all these plots that you see in front of you, they are bivariate plot. If you see the x-axis, can you tell me what is the x-axis over here for the first plot? For the first plot, what is the x-axis? It is price. What is the y-axis? Cut. For the first plot, y-axis is cut, right? So I'm trying to represent two variables at a time, two columns at a time. And one of the very nice plots that can be used for visualizing categorical versus numerical data is called as a box plot. There are many people joining from the Innomatics internship. I hope you can relate to it, right? And other people who are not joining from Innomatics, people who are joining from outside, please go through the other files if you are not aware of all these plots that are constructed in front of you. This type of a plot in data analysis is called as visualization, is called as a histogram plot. All right. And similarly, if you try to see the next plot, this is a scatter plot. Have you ever heard of a scatter plot? This is a scatter plot. There are many overlapping scatter dots in this plot. That's why you see this shaded region in between. But this entire plot represents nothing but the scatter plot. Everybody is able to understand those plots, at least the idea of how the plots looks like. Yes? Perfect. Now let's try to proceed forward and try to see one very interesting thing. In this case study, my task was to predict the price of a diamond. And in order to predict the price of a diamond, we have to follow few steps. And these steps are common for all the machine learning problems you are solving. Let me try to show you these steps. The first step is to identify the target variable and all your input variables. Input variables are also called as predictors. In this case, what is my target variable? Target variable is nothing but a column called as price. And what are my input variables? All the remaining columns in my data set is nothing but they correspond to nothing but my predictors or input variables. Once the data has been split into output variable and input variable, the second step we have to perform over here, always we have to perform this step, which is called as nothing but training and testing data. We have to split the data into train and test. And this is a very simple code snippet to convert your data into train, test, split. And when you make a split on your data into train and test, it gets broken down into these four parts: X train, X test, Y train, and Y test. All right. Next thing, you remember data pre-processing? You remember processing? Can you tell me how many types of data pre-processing I told you earlier? Do you remember that I told you two things under data pre-processing? What was the first thing? The first thing was data cleaning. When I say data cleaning, what do I mean by that? Removing missing values, removing outliers. It all it all is contained inside data cleaning techniques. What was the second technique? Can somebody remind me the second? Yes, vectorization, right? And for vectorization, what I'm mentioning over here is feature engineering. All right, feature engineering, you can call it feature engineering or you call it vectorization. The type of techniques I showed you, they were all vectorization techniques, which are a part of feature engineering. Is that clear to everyone? Right? So what I'm doing here is I'm trying to segregate my categorical data from my numerical data. And after segregating my categorical from numerical, do you see I had multiple columns in my data, but out of all the columns in my data, these three columns were categorical in nature. And if you see bottom table, right, and the above table, the upper table and the bottom table, this table contains all the categorical values and this column table contains all the numerical values. So which table should I pre-process? Can somebody tell me which table should I pre-process? Yes, definitely categorical data I have to pre-process. I have to convert the categorical data to numerical representation. Can I now show you the code to do that? All right, so let's try to have a look into that. The way to do that is by using something called as either one-hot encoding. You remember? Either you can apply one-hot encoding or you can apply label encoding. All right. And this is the code snippet. This is the complete coding snippet. To this coding snippet, if you try to pass those three columns, that I showed you earlier, these three columns, if you try to pass them, what they will give you as an outcome is they will give you the numerical representation of those three columns. And do you see, this is nothing but a complete numerical representation of those three columns. All right. So what are all these techniques? I hope you understand that we have a very limited time, so I won't be able to make you understand like how these techniques internally works. Because in order to understand every single thing, in order to know every single thing about one-hot encoding or label encoding itself, it takes minimum 2 to 3 hours. All right. So let's try to proceed forward. This is how the numerical representation of the category data looks like in simple terms. All right. And once we are done with this numerical representation of the categorical data, what we can do next is, let me not go through these steps. Let me try to jump into the machine learning step. All right, which will give you a clarity on what we can do next. Whatever data we have transformed, all right, the original data was X-train. After applying something called as one-hot encoding, now I have something called as X-train transformed. Whatever data we have received after transforming the data, I will use this data. You remember to what I should pass the transformed data, the numerical representations. Where should I pass those numerical representations? Should I pass them to an algorithm? Yes or no? Now, once I have done all my data pre-processing, should I pass the data to numerical representation? Yes or no? Yes. Right? And which algorithm am I using in this scenario or in this notebook? I'm trying to use something called as a linear regression machine learning algorithm that will help me model the relationships, that will help me model the patterns in the data so that I can make predictions on the upcoming future query data points. What do I mean by all that? Let's not go into the details of it because we are already running out of time. And if you try to see this part, what I'm doing here is I'm trying to simply use a metric, sklearn metric, so that I can see whatever model I have created, using this linear regression algorithm, the model's score is coming out to be 806. Now, what do I mean by that? Let me try to show you this particular slide or this particular table to make you understand it. Do you know my model was able to give a prediction of, there was a diamond which was actually costing 4,733 United States dollar, US dollars. My model, linear regression, I used linear regression to make a model. My model predicted that the price of this diamond is not this much, but it gave a price of somewhere around 5,068. It gave a price somewhere around that. Can you tell me how much error is there between these two values, the actual value and the predicted value? Looks like somewhere around $300, right? Do you all agree that there is an error of somewhere around $300? The actual price of a diamond was supposed to be 4,700. My model is saying that the price of the diamond is 5,000. Right? So looks like that the model has done 300, the error of 300 rupees or 300 like 300 United States dollar USD. Right? Similarly, if you try to see all the following, all these like actual values, there was another diamond which was priced at 6,424. My model gave a prediction of 7,209. Do you agree? At least these predictions, if they are not perfect, but at least they are very close. Do you see they're very, very close, right? $300 difference, or maybe somewhere around like $700, $800 difference. But try to understand that a machine was able to understand some pattern in the data, whatever data he gave to the machine, and it is able to come very close to it, right? Machine is able to come very close to the actual values of the diamonds. Isn't it, yes or no? Do you see that? And these kind of things are something which we can achieve if we know machine learning really well. All right, if we know machine learning really well, we can solve a lot of problems out there in the world. For example, have you ever seen that whenever let's say an email comes to you, the email will either go to the spam box automatically or it will come to the inbox, right? And who is doing that? Machine learning is helping emails or your Gmail or Outlook or other mail clients identify whether the incoming email is a spam email or a ham email or a proper email, actual email that should sit in a inbox. It will be very big problem, right? It will be a very big problem if, let's say, you applied for a job and your offer letter, you, let's say, were able to crack the job, some job opportunity for which you are applying. Let's say you are able to crack the opportunity. What if the offer letter of that job goes and sit inside the spam folder? There are many of us, for example me, I will never check my spam folders. How many of you never check your spam folders? Don't you think it will be a very big problem if these kind of important emails goes and sit inside the spam box? For example, recently only what happened was we shared something called as Inomatics offer letter, like for the internship to lots of interns. We took somewhere around 1,000 data science interns, and we shared like in one single go we shared all those 1,000 offer letters to the interns. And what happened, because of one very simple mistake we did while sending the offer letters, because of a very simple mistake, a very small mistake that we did, what happened, most of those offer letters ended up into the spam boxes of all the interns, and they were not able to understand whether they were selected for the internship or not. Don't you think it is a very big problem for both company as well as a person who is hoping to get a selection, or who is hoping to get a selected or selection confirmation email, right? So these kind of things, right, these kind of things can easily be handled using machine learning if you really know how to do machine learning, or how AI really works. Okay, so there is a very good question. Somebody is saying that we have a model which gave us an output, right? But the output is having some error, right? Guys, are you all able to understand that the output is having some error? Can you tell me what is an on average error by this model? Can somebody tell me from this particular uh, from this particular page, can somebody tell me what do you think is an on average model, on average error of the model? Do you see on an average the model is doing somewhere around $806 ka error? Guys, are you all able to see that? We used this metric called as mean absolute error to identify how much error my model is doing. Akshaya, are you able to understand this part? That the model is doing this much error. Now you ask the question, how do you make the model much better? In order to make a model much better, instead of linear regression, there are many more algorithms available in machine learning. What if I try to use something more sophisticated, more complex than simple linear regression? If I do something called as k nearest neighbor regression, there is another algorithm called as k nearest neighbor regression. If I use that, do you see my error, which was $800 on an average, my error reduced down to only $383. Do you see the impact of changing the algorithm from linear regression to simple k-nearest neighbor regression, right? I was able to bring down the error to only $383, which is nothing, right? So let me try to show you few actual values and predicted values. Do you see that there was a diamond which was costing somewhere around 4,733 in actual? Linear regression model predicted it to be $5,000, but k-nearest neighbor, do you see it is not even $100 difference? The k-nearest neighbor algorithm is able to build a model which is giving a very, very, very good prediction for this diamond. I hope you are able to understand how do you improve, at least by changing the algorithm. That is the first thing that you should see. If it is possible to change the algorithm, maybe linear regression is not capable of understanding all the patterns in the data. So in that case, you use something called as k-nearest neighbor. Now, are we done with all the algorithms? Don't you think there are many more algorithms in machine learning? Right? So let me try to use something called as decision tree regression. Have you ever heard of decision tree regression? So somebody is asking, how do we know which algorithm to use? It is the experimental part of data science. When I say data scientist, as a data scientist, you are an experimenter or a person who experiments on multiple different algorithms, using multiple different algorithms on various different problems. And then that way you try to find out which algorithm suits best for your given data set. There is a much better way. If you are a good data analyst, you remember I told you that if you are a good data analyst, you can do much better in the domain of machine learning. If you are a good data analyst, by looking at the analysis of the data or insights from the data, you can at least give a small guess on what algorithms are going to really work and what algorithms are going to be completely garbage for the given data set. Now, decision tree regression, is it able to do better than the previous algorithm or worse than the previous algorithm? It looks like it was able to improve the performance a little better, right? It was able to improve the performance a little better. Now, the question is, do we have other category of algorithms? And yes, there are other category of algorithms. There are something called as ensembles. And if I use something like an ensemble, like a random forest regressor, I can even bring down this error to only $269, which is a very, very, very good prediction for this data set, for this given data set. Now, my question is, this is done. I'm done with all the discussions for this in this notebook. What if I want to further bring it down? Do we have any other sophisticated algorithm that can even bring this error down from 200 and I think we had $269.59? Can I bring this error down even further? And the answer to that again is yes. You can use deep learning based algorithms. These are all machine learning based algorithms, I told you. Something called as linear regression, KNN regression, decision tree regression, random forest regression. All these are machine learning based algorithms. But if you want to further bring the error down, you can use something like deep learning in this situation. And in deep learning, what is the algorithm name that can help you solve this problem of regression? The algorithm name is artificial neural network. All right, you can use something like an ANN, artificial neural network, to solve the problem of regression or classification. The problem I discussed today is a regression problem. If you want to predict the price, if you want to predict the stock price, or something like a temperature, all these problems can be solved using regression. All right. Similarly, if you want to solve problems where you have to detect whether an email is a spam or a ham, or whether a person is supposed to get a loan or not, in all these kind of problems comes under classification. I have written all these things in my initial notebook, initial Jupyter notebook. You can find it on my GitHub in case if somebody is interested in that. Is everybody able to understand it? Again, this is a very like subjective question. Which algorithm is best in computer vision? Which algorithm is best in machine learning? Which algorithm is best in for classification? Which algorithm is best for regression? It is a very subjective question that depends completely on the problem statement you are solving. Is that making sense? If you really want to explore computer vision, there are thousands of algorithms under computer vision. Please try to give it a quick exploration. You will be able to understand how complex computer vision can really become very quickly if you really try to do that. All right, there are many algorithms under computer vision, starting from simple converting an image to something called as grayscale image, colored image to grayscale image, or grayscale image to colored image. There are many things that goes inside a computer vision algorithm, and in order to properly study computer vision, that again takes a lot of time. All right. So, were you able to understand all the topics we discussed? I hope you had a good learning journey, or you were able to understand the topics we discussed during this session. I'm stopping my screen share. I'm done for today. Um, in case if you have any doubts, or if you face any difficulty during your data science journey, how many of you are not directly related to Inomatics Research Labs? Okay. So in case if there is somebody who wants any further guidance or something, what I would suggest you to do is please try to connect with me, maybe via LinkedIn if possible, so that I have just shared my LinkedIn profile in the in this particular chat section. So if you are facing anything, any problems, or let's say you want any guidance or something, please try to like maybe drop a connection request and try to talk to me in case if you are looking for any guidance or anything. All right. So that's all from my side. Manoj, I think I'm done. Yes, and thank you so much for joining. I was really happy to see the crowd who was trying to interact, who was trying to actually answer all the questions that I was asking. It was a really wonderful experience from my end. I hope you also had a wonderful experience learning all these techniques. If I would have, I just wish I would have had more time to like make you understand these techniques, because see, it is not a small topic or small subject to understand, right? Some of you are from Inomatics. You know how hard it is to understand machine learning, how much time it really take to learn data science or machine learning, right? So it is not a small journey. If you are in first year or second year or third year of your bachelor's, I would suggest you to focus more on machine learning, data science, problem solving, or DSA, data structures and algorithms, if you are from something called as computer science background, because these things are really going to help you become sharp, or understand how the problems can be really solved. All right. So if you need any further guidance, do drop me a message on LinkedIn. I will be happy to help you out whenever I get any time. Thank you so much. Yes, Manoj or Janani, you can take over.
Thank you, sir, for the wonderful session.
Yeah, thank you so
Nothing
much.
is more important than that of returning thanks. Now, I call upon Regina Mary, core team member of GDC Info Institute of Engineering, to deliver the word of thanks.
Good evening, everyone. Thanksgiving is a time of togetherness and gratitude. I would like to extend heartfelt gratitude to everyone who contributed to the success of the Data Unleashed event. Your dedication and collaborative spirit have truly made this session successful. Special thanks to our esteemed speaker, Mr. Kanal Bansal sir, and Innovatic Research Labs team and all the co-hosted GDSE chapters for their support. Thank you all.
Thank you, Reggie. Manoj will share the form for participation certificate. I request everyone to fill this form. The certificate will be provided through mail. Thank you all for your valuable contribution to this wonderful session. Have a nice weekend. After filling the form, you can leave this session.